connected semi-permanently to the speaker and amplifier. But you can see here, when we're dealing with servos, we can talk to, oh, why is this one saying A1 and 2? Oh, are these the only pulse width ones? I could be crazy. Maybe we can only do 2 of them. Something that will be remedied with the Cricket, I might add. But, okay, so take back what I said there. A1 and A2, those are the ones that we can send servo pulses out on, because those do PWM. And if you look elsewhere in my code, I'm doing these servo writes. And so here again, on either servo that's on A1 or A2, I can send the servo to an angle. So if let me duplicate this one and blow away this variable here because it's getting ahead of myself. This is what this block will typically look like. Oh, I can wear it as a mask. It's kind of fun. So this would send servo A1 to 170 degrees. So if we grab our little friend the servo here, and I'll put one of those, it's actually kind of hard to turn the shaft without those servo horns or arms. What are they called? Horns? So if I put this guy on here and line him up where you can see him. Whoops. That sounded worse than it was. So that might be 180 degrees, 90, and 0. So we could go to 170, which should be almost entirely that direction. I think I don't have those backwards, but if I do, you'd flip those. So typically you could send the servo to an angle. There's another type of servo that's a continuous rotation servo, and we'll be using those in other projects down the line, not today. But for your typical servo, it's going to go to an angle and stop there. So let me delete that block. And I don't want to complicate this too much, but one thing I did was I was calling servo angles a few different places, and as I was testing and changing those numbers, I didn't want to keep updating it everywhere, so I created these 2 variables. And if you head to this variables category in MakeCode, you can make a variable. So let's say we want to make a new variable that's called rest angle. Maybe this is where we want it to always return to for some reason. So you can see now I have a new variable block called rest angle. And if I take one of my set, and it picks the first variable alphabetically to put into this drop-down menu, but if I bring in a set and drag down to rest angle, we can say set the rest angle to, let's say it's 78 for some reason. So if I place this into my onStart block, this is one of the things that gets initialized right at the beginning of the code. And so then throughout the rest of the code, if I use one of these servo write pin A1 or A2, instead of typing in 78, I can grab an instance of that little variable to reuse just by grabbing this rest angle and dropping it into here. And so now I've said servo write pin A1 goes to the rest angle. And if I have that sprinkled out throughout the code, maybe there are different things that cause it to go to the rest angle, I only have to type that number in one time, which was in this initialization or onStart block. Oh, someone said YouTube seems to work now. Are we streaming? Are we streaming to YouTube? That would be terrific. Hey, all right, we're on YouTube. So YouTube, sorry, we had some difficulties with the stream starting on YouTube today, but I am recording this video and will re-upload the full version later so that you won't have to wonder what happened at the beginning of the show. But thank you for tuning in, and if you're just joining us or just catching up now, the topic we are on is, at the moment, this is the MakeCode Minute, which I admit has gone on for quite a bit longer than a minute, where we are talking about using servo motors, these guys, with Circuit Playground Express inside of MakeCode. And so I have initializations here where I use some variables to set, and I'm actually not using this one, so let me delete that block. And I'm going to also, if you'll bear with me for a moment, I need to go back out of the dashboard of YouTube and onto this video and then pause it or hide it, because otherwise I see a delayed echo of my own video, which is distracting and weird and can cause black holes. Yay! I wonder if Facebook caught up too. All right, so let's pop out the chat. Live chat. Pop out. Super. Dexsaurus, it is your birthday. Happy birthday, Dexsaurus. Thanks for joining us in the YouTube chat. Good. All right, we're taken care of. We're up and running. Thank you. Thanks for fixing your stuff there, YouTube. Very nice. Okay, so servos in Circuit Playground Express using make code. We have initializations here. And so what I'm doing is setting a servo on variable that I created, which is my on or off state for the servo. It's not a perfectly named variable. What this one means, oh hi, I'm hiding from you. What this one means is I'm going to use the switch that's built on the Circuit Playground Express to switch between the servo running automatically on its own back and forth, or waiting for button inputs. So this is what this variable is going to serve for. And I start off with, let's expect button inputs. And so in that mode, I've created, using these input blocks, on button A, do something when you click it, and on button B, when you click it, do something. So let me delete that one because I already have one here. So on button A, what I do is I send the servo pin A1 to the maximum angle, which is a variable I had set up here. It's 180, so all the way in one direction. And then I'm also setting some neopixels to blue and sort of pointing the arrow of those neopixels in the direction of travel. When we press the second button on the Circuit Playground Express, so this guy here, we send the servo to its minimum angle, which is 65 degrees, and we set the lights to blue going in that opposite direction. Now, if I use this little switch, let me peek out there. Am I there? Hi. If I use this little switch that's built onto the Circuit Playground Express and head to the left, then that tells the servo to go to 120 degrees, so wait there, and know that we're in this button mode. So that's this servo on, which really should be automatic mode or button mode. If I flip the switch to the other side, then it also sets it to 120 in case it was somewhere else, and then it switches this servo on variable to a 1. I'm also color coding things, so in, oh, did I get these backwards? Yeah, I kind of did. I'll leave those alone. Only in the interest of time. But when I go to this servo on 1, then what we're going to look at is this forever loop. And what you see in this, I'm going to close the piece of the interface there. There we go. So what happens in the forever loop, which you kind of can only see that word forever. I'm going to put it on my shirt. Forever. There. This forever loop is what happens all the time. And so every tick of the program it runs through, and what it's going to use is this logic called an if-else statement. Actually, this one just is only doing an if. It's kind of doing nothing if the condition isn't met. And the condition I'm looking to meet is the servo on variable set to or equal to 1? And when it is, which means I've switched that little switch to the right, then we're going to move the servo to its maximum angle. We're going to show that color ring as red. We're going to pause half a second. So that's this pause 500 milliseconds right here is. Then we're going to, I can zoom in. Then we're going to go to the minimum angle, set the color lights in the other direction, and I'm pausing for 200 milliseconds. So it's an uneven motion or uneven timing. Okay, so that is it. And then what I do is, let's do this for one of these. I have a couple Circuit Playgrounds out. Okay, so here's the Circuit Playground Express. And this is one that I've actually bolted to a cool little, I just printed a second one of these, printed one yesterday and one this morning. This is a cool little standoff or mounting plate that the Ruiz brothers made that you can use to connect a Circuit Playground Express to kind of anything you want. You got these two nice little holes here, but they made it expressly for these cardboard screws that we have from a company called Make Do, and we sell those in the store. Maybe someone can put a link for that in the in the chat, but these are these little cool plastic screws that screw into cardboard really nicely, and they just made that diameter fit so that you can bolt your Circuit Playground Express. So that's why that's on that little funny red plate. And so what I'm going to do is plug this into USB, and then I'm going to head to bootloader mode by, whoops, clicking the right button. There. There we go. So it's gone green, steady green, and that's waiting for me to upload code. So if I click download here, it'll ask me to save that to disk. Actually, it just saved it to disk for me. And then you won't be able to see this just because I'm not opening a window to do to screen share that. But what I'm doing right now is going to drag and drop the file I just downloaded, which is called Circuit Playground. Make this big enough to read. servocycle2.uf2. This is universal flash format. And I'm going to drag that onto this shows up as a USB drive called cplayboot. And so when I drag that on there, it just flashed, it loaded it, and now it's ready. So when I press, whoa, I'm touching the, so when I press these forward and back buttons, it's doing the little blue thing. If I switch the little toggle switch there, it's going to go red and flash back and forth. So what it's also doing is sending those PWM signals to a servo. So let's, what I'll do is I'll hook up this guy, and I can hide our make code for a second. Okay. And let me grab a set of, so remember these little guys that I showed earlier, these cool small alligator clips. So if I take 3 of those, and I've actually taped their little ends together, so it kind of looks like a 3-hole connector jack. If I plug those in to the servo, I've got those lined up for signal, power, and ground. For some reason these servos use brown for ground, but that is ground, and this orange for power, and then yellow is the signal. So I kind of match them with my alligator clips. And now I'm going to connect, let me put this somewhere where you can see it, to, what did we say, A1, oh, I'm upside down. There. You should normally power things off when you're plugging them in, but we'll live dangerously. This black one is going to go to ground, and this is power. And so now, you can see we're going back and forth between those two minimum and maximum angles. If I switch to this other mode, I can now use the buttons to go back and forth. Okay. So that was the make code many minutes, not quite a minute. But what we'll do is we're going to set this down for a second, and then later we're going to hook this up to our cardboard construction that we're going to make, which is coming up in a moment. But first I want to do a tools and techniques segment. So that's also going to bother me that that thing is not sitting in the right spot. Watch this. Ready? Hi, everyone. I wish I had checked chat sooner. So that went on for like the last hour? Yeah, I don't know if that's... You tried calling my phone too? I think I probably have it... Yeah, there's a call. 14 minutes ago you said I was muted. All right. Well, that would be nice if it was only just 14 minutes ago. This is a fun show here today. Everything has gone a little screwy. All right, well, let's ask people what the heck was the last thing I did that you heard 14 minutes ago. It was probably when I walked over to the other side of the workbench, wasn't it? Yes. Hi, yeah, nice to be here. Hi, everyone, I'm back. My audio was off, huh? After I walked over to the bench, 28 minutes. Oh, that's awful. The whole experience of the bench was silent. Well, let's see. I don't think we've got anything going on. I'm just going to redo all that, except I'm going to do the sort of streamlined version of it. How about that? We're recording this. We'll rebroadcast it. Yeah. Awesome. Are you guys ready? You ready to buckle up? Hey, no worries. It's a free live show anyway. Yeah. Oh, man. I really, really, really need to build some kind of an audio alert monitor thing. I bet someone pinged me on HipChat too, didn't they? Yeah. You know what? Sometimes I've seen HipChats pop up, but I didn't today. I think it's because I have the audio down. Kelly Devine just also let me know. Everyone at Adafruit has let me know that the audio on the live stream broke. All right. Well, that was a fun 28 minutes that we're now going to repeat, but this is going to be so much better. Yeah. Oh, thank you everyone for all your support. I've gotten a lot of messages about this. So, well, if you like watching the show live, I hope you have an extra 28 minutes because we're going to kick that. Oh, you guys, Katney says that the community stepped up with great subtitles. C. Grover says he appreciates take 2 because he was late. All right. Let's do this, yo. Yeah, huge red LED that lights up when the audience can control my audio. We're going to do something. This is going to be a community project to make me stop talking into thin air. That'd be so great. I can't believe how many different ways people tried to let me know. All right. I think I'll leave my phone off of mute next week and see. All right. Are you guys ready for cardboard time? Check it out because it is tips and tricks, and I'm John Park in John Park's workshop for Adafruit, and we're about to just blow your mind with cardboard, all right? So let's do this. So I'm going to head over to my workbench, and I'm going to keep an eye. Yeah, I'm ready, Yannick. We're ready. I'm going to keep an eye on that window right there. So you tried shouting to no avail. Thank you. I think we're in good shape. I'm going to watch that as I switch camera over. Because there's a weird chance that switching camera is what flipped the audio. It normally doesn't. Can you hear me still? Yeah, okay, good. All right, that looks good. So this is so much better. This is going to be so much better than take 1. So cardboard. What I want to talk about first is different types of cardboard. So let's pop in that overhead. So there are essentially 3 different types of cardboard. You may have seen this, but you have not heard this yet. So we have paperboard, also called chipboard. And paperboard is anything from delicious Captain Crunch, peanut butter Captain Crunch. I actually prefer Crunch Berries, but this is what we had, which is a very thin paperboard, also called chipboard. And it is a single ply. It is also what you'll find in the back of a notebook. Let me give you this version, the big version of this. And it is a pulp just like paper or cardstock. There's actually very little difference between cardstock and chipboard or paperboard. It just tends to be the bleaching or not, the finish, and the thickness of it. But you can make a single ply cardboard or paperboard. These are pretty good for some projects. I used one for just having something to glue down my copper tape to do this drum pad I had made last year with Circuit Playground Express. This is one that played WAV files back. And so I was able to trigger these, sort of like Colin Cunningham showed. He has similar copper tape just glued down or taped down onto his desk, and he uses that to trigger drum samples in his audio software, his DAW. So we won't use this quite as much because it doesn't tend to have a lot of strength. It flexes quite a bit. For some things, that's great. You can make sound effects with it. You can fan yourself with it. But for the most part, we're going to focus on our good friend corrugated fiberboard. So corrugated fiberboard is the term in the box making industry for what we call corrugated cardboard. And so that is going to be your typical Amazon box, that's going to be your Adafruit boxes that we ship things in. And actually, you'll notice with a Adafruit box, you have this pretty thin, I won't get out the calipers, but you'll have a pretty thin corrugated fiber board versus a Amazon box, which is almost probably 50–75% thicker. And so the corrugated cardboard or corrugated fiber comes in different thicknesses. It also, as you can probably tell, here's a nice one. This is a DigiKey box I got. They sent me a bunch of empty boxes to build some projects with. So we're working together on some AdaBox stuff. So here you can see, actually, let me give you a really nice view of the structure. Oh my gosh, I'm so happy my audio is working. How's video? Is that working too? Yeah, okay, we're good. I'm going to be so paranoid about the audio now. So let me swap over to this little down shooter here. So what you'll see is a typical corrugated fiber board is 3 plies. So there are 2, that didn't quite want to focus. Let me put a hand up here. Most things want to focus on a hand pretty well. I think it's just too close. Hold on. There we go. So let's see, did I get this light on earlier? Oh, that light is on. You can see we have a facing material, which is pretty much the same thing as our paperboard or chipboard. And then we have this row, this inner wall of flutes is what these are called. These are these corrugations. And this wavy pattern is particularly strong structurally. It's a brilliant design, honestly. It's why it's been around for a long time and it's so ubiquitous. And then we have a second face. So if I peel this back, you can see we have this fluting on the inside. And there's actually a single face corrugated fiberboard which looks like that. And so if I dig some of this off, and so what we're left with here is a very thin fiber paperboard or cardboard. And then I'm going to do a no-no, which I'll talk about more later, which is using scissors, which you really don't want to do because you tend to dull your scissors. Anything that you cut with cardboard is going to dull quick. So it's not the worst thing to do, especially if you're in a school setting and you have inexpensive scissors that you replace a lot, or if you have some really nice ones that you sharpen regularly, I guess that's fine too. But you can see here, if we have a single face and a single wall of this fluting, you end up with a very flexible cardboard. And so compare that to, let's get a roughly equal size piece. Okay, so this now wants to bend along this grain, not quite as readily, and so we get this sort of hexagon shape because of this wall, which has to go somewhere. So you'll see there's a collapse in that corner, and that's something we'll deal with when we're doing more precise construction. But anyway, that does exist out there. You just don't see it that often. Sometimes used as a packing material. You will also find, so I mentioned grain. We'll talk about that more, but you'll see that it's quite rigid along this axis, which is against the grain. So it doesn't really want to bend nicely. You'll see I'll have a hard time making a crease there. I make a big mess trying to go against the grain, whereas with the grain, just like with wood, there are advantages and disadvantages to going in those two directions. You will also find that there are, this is called a 3-ply because we have 2 faces and a wall. There's also 5-ply, which and there's 7. So 2 of the stronger types. Let's see if I lost my. I had some example here. I'll tear another chunk off if I can't find it. There's a box I got at All Electronics, in fact, when I bought all those cassette recorders. I'll tear off a piece of this, and I looked at it, and it's actually a 5-ply. So this has wall, flute, or rather face, flute, face. So there's the 2 outer sides, there's a bunch of tape there, and then we have this kind of sandwich of Let me cut a neater piece of this. Ooh, that's dull. There's an example of knowing your knife is dull. I can grab a different one or break off one of the old. Let's see how this does. We're going to talk about cutting in depth later. Okay, so you can see a little better here. This is this multi-ply construction is 5-ply. And I even found this, I forget what this was in. This might have been in one of the Nintendo Labo kits, but this is a, let me go to this camera for you. This is interesting because the flutes are actually oriented in this axis, what I'd consider kind of a y-axis in a 3D coordinate system, instead of along the x-axis. So if we peel off some, you'll see there's flutes, kind of almost like a honeycomb thing, that give this a strong compression strength, which is not the case with our more typical corrugation. If you try to pinch or compress this, it compresses very easily. So you can see the compression of the flutes. It's dead easy in this axis, very difficult pushing down on it. And that's intentional, right? Because that's the wall that you don't want crushed of a cardboard box. This one actually flips that around 90 degrees and becomes a very tough compression one, but you could probably still bend it in these axes easily. So that was just used to prevent something from getting crushed in shipping. We'll be dealing mostly with corrugated, and I'll come back to that. I will mention a couple other things. Typical cardboard tube, this is just from inside of wrapping paper, is a spiraled and glued piece of paperboard, pretty thin in this case. And then there's this mat board. So mat board is what picture mats inside of a picture frame are made of. And these are similar to paperboard, but they're a laminate. So there are different materials. Let's see if I can zoom in enough and focus. There. You can see on the mat board, there's a kind of cardstock layer that can be a different finish and material than the core. This is often colored. If you look at mats, often when they're cut on this bevel, you see a white core show up. So there's this core. It's similar to foam core, but it's not. It's also a paper product inside here and not foam. But you can think of it as a little bit like a foam core. And then another layer of this paperboard on the outside here. These can be the same finish. They can be different finishes. Sometimes this side will be like a archival anti-acid stuff, and this might not necessarily have to be because it's not touching it. Who knows? I don't. This is the stuff that Bunny Wong used for his cardboard circuits post about doing SMD circuits on cardboard. He prefers this matte, and you can get it with different finishes too. I think sometimes this finish might have a little bit of waxiness to it, or shine, or matte finish. So, and the different colors are kind of cool. So we won't be using that as much, but our best friend is going to be the corrugated fiberboard or corrugated cardboard. Okay, so that is awesome. We just got through that, and this time you could hear me, so I'm pumped. Now what we're going to talk about is, I'm so glad for live internet versus live TV, because you just don't get a chance to go back and redo 28 minutes on live TV. Let's talk about marking and cutting. So I'm going to pull this one out just a little bit more and talk about tools that you want for cutting. So you can get away with very little. Obviously, anyone with a pair of scissors can make stuff out of cardboard. If you're trying to do things a little bit more precisely, or you're doing a lot of it, you may want to splurge and get yourself a few tools. So one is a nice cutting mat. So this is a pretty big one that I got very recently. It's 18 by 24 inches, and it only cost $30 at a craft store, and I got a 40% coupon on top of that. So pretty cheap to get a nice self-healing cutting mat. And they also usually will have dimensions and angles used for typically pattern making and sewing and cutting fabric, but you can use those guides for you. I have previously, I've had these, and they work great, just these little ones. I've had this one for years and years, and it still works just fine. You mostly want to avoid just cutting into your dining room table or into a hard surface that's going to dull your blade. So these don't dull the blade, and they're, you don't care about this surface like you do your mahogany heirloom Ethan Allen dining room table or whatever it is. So cutting mat's a good idea. If you don't have one, you can lay down some magazines or newspaper or other sacrificial stuff. So that's not a necessity, but it is nice to have. For cutting, you want a hobby knife like this, little X-Acto I have here, but any brand of hobby knife. This is either a 10A or an 11, number 10A or number 11 blade tends to be the common ones that come with it, and they work great. Just get yourself a supply of replacements so that you stop using them the moment you feel that they're dull. So we'll talk about the basics, and then we'll get into some more specific tools. But you can use that. Don't use your scissors, like I said. Don't use your pocket knife. I do have one of these, which is a contractor utility knife, and they have replaceable blades. This one's really dull right now, so I'm only using this to just kind of cut tape. But you can... Ooh, someone in the chat, Mr. Certainly, just has posted, if you're on Discord chat, a tool to put a new edge on an X-Acto. That's excellent. That's a great idea. Probably it's like a little honing stone or steel, like in the kitchen, right? Just to lift the burrs up. That's cool. I'd never thought of that. So you've also got your, like this one I showed, this one's kind of dull, so I can use that little thing on the back here. I'm going to put on some safety goggles first. And, oh, let me give you the big view. Usually there's something on the back of these cheap replaceable snap-off blades. This is a long section of blade that's got perforation, and so you pull this back to about there, and then the thing that comes off the back is used to snap the old blade off. It goes flying and impales someone in the forehead. Dave Peskowitz at Maker Faire style, and then now you've got a new sharp blade. So let's see, that's probably good on those blades. I'll get into some more specialty stuff in a second, but get yourself a hobby knife. You won't regret it. Some extra blades. Now for marking, measuring, and cutting, I recommend, look at this sacrificial DigiKey box. Thanks, DigiKey. Thanks for the box. Actually, I'm going to do an unboxing of the boxes because I got a bunch of them from them. So I used to have a little 12-inch version of this metal ruler. I lost it, so I picked up an 18-inch one, which is nice for some of these bigger cuts you're going to do. You can see this will cover, zoom this one out. This will cover that whole box right there with one cut, which is nice. And I recommend a metal ruler because if you use a plastic ruler, what tends to happen is you will slip. And this is not for marking, this is for cutting. So any ruler or straight edge you want, you can go and mark up with a pencil to your heart's content. But what happens with, and I'm going to switch to this little close-up cam here. What tends to happen with a plastic edge is that if you're using it to guide the blade, the guide likes to either cut into or ride up on top of that edge, which is actually dangerous. So if you're holding a plastic ruler down and you're cutting, a little twist of your blade and it skitters right up and across the plastic and boom, right into your finger. Or you'll kind of take chunks out of the plastic and ruin the edge. But the bigger worry is just that the plastic ruler tends to be beveled like this to get the edge very low to the work surface, and the blade loves to just skip up on top and hurt you. So what I recommend is a metal ruler. I have found that these fiberglass PCB rulers that a lot of you might have, I think one of the original ones is the little Adafruit one, which I think I've got here. and then this red one is this DigiKey one. So these fiberglass rulers actually work a lot better than the plastic ones. They have a straight edge on them, it's not beveled, and it's not as soft as this PCB material is not as soft as the plastic. So those work pretty well. But you might want to save those and not get them all scuffed up. So any little metal ruler that you can get, particularly with a cork back or some other non-slip surface, is really great. So if we're just trying to do, let's swap out the camera here. If we're just trying to do a little cut here, let's say we want a little 1 inch, so I'm just going to mark here, by 4 inch, so mark here. You can, oh, I'm going to put my head right in the way, aren't I? Let me zoom this camera down onto here and be moderately careful. There you go. So, you know, this is fine. This will work pretty well. I'll show you another tool that I like to make this a little more precise. That wasn't well done there. So I think that's square. I'm not quite sure. I should have measured a few places. But either way, another thing I'll recommend is don't cut at an angle that's awkward. Sideways is awkward. Diagonal, less awkward. Towards yourself, maybe awkward too. But I like moving the work and moving the guide so that your cutting angle is comfortable and safe. I kind of wrote up off of that. That's not a great cut. And so you can see I'm not leaving the work where it was and then going and cutting at a weird angle that's awkward. I'm actually going to move everything and then come and make the cuts. So here, I probably should have done some more measuring to make that accurate. Here I want to show you a very cool specialized tool that I don't know how common these are. I got one as a gift from my wife a number of years ago. This is it's called a check edge. And I had never heard of it, and I was thrilled when I got it, because just look at that thing. It's this beautiful machined little kind of ball screw vise thing that just clips onto your ruler and allows you to do two things. It allows you to mark a depth that you want to make repeated cuts on. And so I can go here and say, okay, I'm trying to get exactly 6 1/4 depth over and over again. Sorry, let me refocus. By the way, I'm not using autofocus on this overhead camera because it flips out from the cutting mat. This high contrast surface just wigs the autofocus out. It is the opposite of what autofocus is trying to deal with, apparently. So this gives me a repeatable depth without really looking. I know if I go along this piece. Sorry, zooming out again. About there. Let me try to focus again. Good. So I know that I can mark out, let's say, something that's that 6 1/4 a bunch of times. And the other thing I really like is with my cutting mat square to my work surface, I can zoom out just a little more so you can see this. I can use this kind of like a T-square to make a parallel set of lines. And I can even use the markings on this cutting mat to get fancy and do every inch or whatever I'm doing. So this is similar to like a drafting T-square, but it's probably higher quality and cheaper to just take a nice metal ruler that costs less than 20 bucks, probably less than 15 bucks, and this guy. Although that was a gift to me, so I don't know what it cost. Maybe it's priceless, who knows. But I'm guessing not. I love it, though. So now you can see if I line up my work with the edge here or one of the lines, and then set this here, it's big enough that I can get a nice stop there. And now I can start marking out whatever it is that I'm trying to mark out and cut. So let's see, that is a few cutting tools. Now let's cut that out. I don't mean stop that, I mean let's actually cut this. And we might use these later for our project. How long is this show going? Is this going to be like a 3-hour show today? I only lost 15 minutes at the beginning and 28 later. Also having this little, like this little ruler that I got that allows me to, I'm just eyeballing that angle there, but allows me to leave this little check stop on that ruler. I'm cutting through 2 layers of the cardboard here, so I don't know if I got it. You can go back through once you've made the cut. You don't need the ruler there if you're just lightly allowing the tool to guide you and just cut through that rest of the fluting and the other side of the back side of the face. I think we might be going through, no, I think we're just going, nice box there, DigiKey, it's a thick one. I think we're just going through the 1 layer. Okay, so there's our little piece. Now, one other tool that you may find really useful, and again, you can get away with just a hobby knife is fine, scissors, that can be fine. If you're doing a lot of cutting, if you're doing a robotics curriculum for a class and you want to make some cuts in advance, you might want to get a fabric cutter like this, a rolling fabric cutter. I've actually got a special blade on here. These are called skip blades or perforation blades. But if you put the regular blade on there, you can zip through stuff really fast. There's something about the rolling sharp blade versus dragging a knife through that works really well, and it seems to stay sharp a long time. If you put on this little skip blade, the nice thing is that you can get really great folds predetermined, and they can be with or against the grain. So remember this corrugation fluting, zoom this in, has a grain to it, and so it wants to bend. It's pretty easy to bend it on that axis. If I want to bend on this axis, I need to score it in some way. I may even need to remove some material. So by using this, and let me grab a ruler here, take that off. If I need to put a bend right there, there are a number of ways to do it, but one of them that's really snazzy and handy is with this fabric cutter. Whoops. Let me pull towards myself and not cut towards my hand. These also kind of seem to want to go in a straight line. You can push hard and go all the way through, or you can go just partially through. It's fine if you want to go through. In fact, because of the way the wheels work, you can line up with the last cut and carefully retrace your steps, and it's going to stay geared into there. So now I've poked, let me pop over to this camera. Now you can see a little bit there. I've poked into, as I bend this, you'll see, you see little perforations there. And so now it's very hard to bend these in the anti-grain direction until you cut or perforate. And so now with this little perforation in here, you can also bend it up on a ruler. That can help. You'll see now we can get a really nice fold there. Using that little skip cutter. So you might need to reinforce that, you might not. This has one side where I'm actually going to cut this intentionally so that we get a nice open. So on one side it's not even perforated, it's cut all the way through. Inside it's perforated. So this gives us a really nice cut and a nice bend. Another way that you can deal with those is by cutting out, let me make sure we're focused here, cutting out a channel. So let's try to do it with this one as well. So I'm going to put a couple marks in this, sometimes it is easier to mark it and cut it and not just try to cut it. So that'll be one. That'll be another. And the issue is that you can't really compress the cardboard infinitely into itself. So by removing a little channel, you can get a nice bend. So this will be bending opposite direction of that first one. So this time I'll just go with the X-Acto, and I'm only cutting through the face and through the fluting. So you just kind of have to be careful to not press too hard and go all the way through. And then I'm moving over a millimeter or so and taking out another line, and then we'll be able to peel out the facing and the fluting, or just the facing, depends on how sharp you're trying to get that bend. And you can go in with your knife, or you can go in with some tweezers if you want to be careful. So you can see we're lifting that facing off. Let me be a little safer with this and use some tweezers. I'm going to cut that some more. Again, I'm just going to follow the cut. Those tweezers didn't work for that very well. And right now, we don't actually have any bend on or crease on the other side. So we'll probably get a rounded. Actually, I'm going to cut this in half so that we can show two different bends on this. So with this one kind of dug out, I'm actually going to grab, this is a ballpoint pen that's completely dried out. It's a decent tool for flattening that fluting out. And now you can see I'll bend here, and the inside of the bend has somewhere to go. Right. We can also really crease the back side, the back face, from this front side. So I'm just going to put down my guide here to be a little bit precise about it. And I'm going to try to move the whole thing so you can see it better. There we go. And now, just drawing really hard with my dried out pen, that just put a little bit of a fold into that face, so I can go back and forward and have a nice crease again that matches the stuff I cut out. Now this time I didn't groove this stuff out very well, so it's still kind of binding up, so you might want to go in and peel that stuff out. Okay, so let me see if, I'm just going to switch over to my notes real quick, if I can find a cursor, and make sure I'm not forgetting anything I wanted to show on cutting. Okay, so a much less exotic thing than our fabric cutter is the hole punch. And the hole punch is particularly excellent for creating holes for axles and making connections with belts and pulleys and yarn and those kinds of things when we're making mechanisms. So I just have a single hole punch that you can get at the office store. This one does a 1/4 inch hole, which is nice. I've added some little white marks that help me identify where the center is a little better than it did by default. So if I'm trying to line it up precisely with, let's say, that little dot right there on one axis, and then I have a dot here that I'll push back until it's where I need it. And you can get nice fancy ones that have a really deep throat to them so that you can go further into the material. I don't have one like that, but if you look in particularly scrapbooking, it has those. I also have my regular sheet metal die punch, and that'll work well for getting a deeper cut and picking your hole size. But anyway, these are great. Any kind of hole punch will do. Little, those little sort of cheap metal hole punches that you have at school will work great to put some holes and make a nice little robot-y face, or whatever you need to do. Okay, so I think if there are other cutting and marking things, I'm going to cover them another time because I want to get on to the next thing. Yeah, so we'll cover some circles and some other more exotic things another time. But let's now switch over to our build for the day. And I'm just checking all my chats again. Someone in the chat said it's such a polished presentation, it's almost like he practiced. Yeah, if you're just joining us, I went through 20-something minutes of this with my audio off, so I got to do on take 2. Right, on to hour 7 of the show, the actual project. Holy cow. So let's see, is this the, look, I have that. I have text that says project build, so project build time. So earlier in the show, we built the little servo motor control with the Circuit Playground Express. And what we're going to do now is hook this up to a little slider crank mechanism that we can use to puppeteer something. So I'm going to let me show you one I've built. And then I'll show you the steps towards building part of this. And we may go a little simpler today just because we're running out of time. So what I have here is my little, let's see, is this running? Okay. Something's funny about this one, but okay. So what we have is, I think let me power this one down so that I can actually move it by hand. We have a mechanism that's called a slider crank. And says it right there at the bottom, slider crank mechanism. So this servo is rotating, and is it stuck still? Do I have to power you down? I think I do. Let me pull his power. There we go. So this rotation, peel that off. I guess I didn't screw that down. Is responsible for driving this connecting rod, which will push our piston, right? And I'm just checking my notes here so that I say things properly. Sorry about that. Yeah, so we have a popsicle stick as a crankshaft. So that's this little one. That's the crank, just like you would turn a crank. And then the connecting rod connects it to this pivot point here, which then pushes the slider or the piston if this were like in a pump or an engine. So what we're going to do is we need, for this to work, a frame to hold the slider from rotating, and then that will allow the rotational force of our servo to transfer into a linear rotation on this slider arm. So you can see as this rotates back and forth, move that a little bit more this way, it will turn into, whoops, you can see that, just the linear motion of that popsicle stick. So this is one way to transfer the rotational force of or motion of the servo into a linear force or linear motion on the end of that slider. Okay, so I think, yeah, since we've run out of time, I'm just going to show you the method I use to make the popsicle stick sliders, which is very straightforward. But instead of making a whole fresh new one, we'll just attach a puppet to this one and use it. So let me switch to, and take off the text from here and go to Workshop Cam. Bear with me. Okay. See, this is the part I didn't get to practice for free one time, so now I'm having a harder time with it. Rehearsals are a luxury that we don't really have in live streaming. So let's see, here's some popsicle sticks. And this is a great use case for our hole punch. So what we can do is line up in the center, there are little guides, a little hole there. Oh, I didn't center that well at all. Let's try that again. Much better. Okay. Luckily, we need a short one. So from this one, I'm just going to take some scissors and cut this shorter, like so. And then I'm going to use hot glue to connect our little servo horn. You know, let's use this big one. So since we have this hole here, we can fit. Yeah, we can get that on there pretty good. I'm going to bore that out a little bit, I think. Grab a reamer. There's a little lip on this axle of that servo horn. So I'm just going to drill that out. Okay, that'll fit flush on there. And so that little hole is used to, by having that there, we can also screw down into the servo, which isn't always necessary, but it's nice if we want it to be on there securely. So I'm just going to hot glue that on here. If this will reach, yeah. Let's do the stick. You can blob it on there pretty good. You just want to make sure you don't get it down into the mechanism of the servo. So like so, and we'll let that cool. And here's our servo that we're going to use. So it's going to sit on there like that. And then let's put a, I could probably have done this before, we'll put a hole in the end here. Oh man, I'm doing terrible with this spacing, but that's okay. It won't hurt this project. And so now we're going to make, from this crankshaft, we're going to make our connecting rod. So trying again for a decently centered hole. That's better. And what we're going to use to connect these is, just because it's cheap and easy, we're going to use these little round head paper fasteners. And so all we have to do is set the two popsicle sticks together and splay out these arms, and then we can kind of fold them back in towards the center. We want them to hold it but not get caught or in the way. And so now that'll pivot freely as this rotates. Whoop, you can see what it'll do. Now on a reciprocating slider crank, if I can hold that well enough to do, let's see. Yeah, there we go. I can set that on something. I'm kind of using this backwards, but the motion you'll get is this, where the rotation of the crank will push and pull and push and pull. We're actually using a non-continuous rotation servo, so we're going to do this kind of action. And now let's take this crankshaft, or rather this connecting rod, put another hole in it, decently centered, and a hole in what will be our actual piston or slider, and we can connect these. So same thing, we'll take a little brass fastener, paper fastener. I can put this in this camera for a second. There you go. Like so, and like so. So that holds pretty well. You know, there's some slop in there. That's actually probably okay for our needs. So if, you know, a lot of the cardboard parts might not be super precise, but with a little bit of slop in there, everything should move okay. And so now you can see, let me pop back out to this camera. Now you can see if this pivot of the crank is in line with the pivot of the slider here with a guide. So we'll build a little guide. Then as this rotates, it will take that rotation and turn it into that linear force. Okay, so we can swap out this. Let's go find out where our full rotation is. So that's fully forward, and that's probably good. And then this will come back a ways. And now what I can do is I can, I won't worry about that screw. That will hold it on pretty tight just by squeezing it down. And so why don't we actually hook this up just in free space and we can see it in its auto action mode. One thing I found is that I think we're potentially stalling out this little motor when we draw a little too much current over a USB connection when it's just connected to the computer. So it's either good to use a battery or a plugged-in USB connection. So we won't need our hot glue anymore. Let me move that, and let me grab a, let's see, if I've got a LiPo battery or a, yeah, I'm just going to grab, oh, here's a LiPo. This should be okay. So I'm going to plug this LiPo in. Okay, let's hold that still. I'm just gonna, okay. So that's back, and that's forward. Yeah, that's pretty good. Okay, so I'm gonna put it into its auto mode, so it just goes back and forth, and you can see if I get some guides on there, let me hold it from underneath. So it'll be able to move that forward and backward as this rotates. But my hand is not a good piston block for that, so let's build that. And here's where we go cooking show style, and we swap out for, hey, voila. So here is the same mechanism, but now I have this sort of piston block to guide it. And I can plug this back in. So by the way, we have this very cool, fancy, purpose-built, 3D printed, designed by the Ruiz brothers to bolt the Circuit Playground Express to the cardboard. Before I built that, and that's what we won't use that on this one because we're running out of time, I used a zip tie plugged through the Circuit Playground Express and a small hole, ran it through the other side, and then you can put another zip tie through the back to hold it in place. For now, we just have that single zip tie kind of pinning it there. So let's hook this to 3 volts. And let's see. Was this the one that was acting mad at me? Is this one out of... oh, that's just getting weird pulses. Look, it's going the wrong way. You're bad. You're going the wrong way. What's happening, servo? That sounded more normal. Oh, I think it's this hot glue. I added this extension, and I think that's getting in the way. Yeah, so by the way, some of the things I'm doing here are a little bit pushing it for the Circuit Playground Express on its own, which is one of the reasons that we'll be doing a lot more with a better solution with Cricut, so that we're not fighting the current draw. Yeah, let's try that other one. I don't know what's, maybe I have something weird programmed on that one. So let's swap in this other Circuit Playground Express and see if he's happier. Let's see, should be A1. It should be ground. And boy, I'm so happy to look up and see that the audio is still running. And 3 volts. Is my servo gone nuts? What's happening, guy? This is doing the same thing. It's like kind of ticking. It was A2 or A1, right? Yeah, it was A1. All right. Other battery. All right, let's swap the servo out. It's real-time realness here. What could be going on? And these are, yeah, this is properly plugged. All right. Servo transplant. Let's just try the servo on its own. And ground power signal. This one has a different color. Ground power signal. Let me just for kicks plug in a wall wart in case those batteries, which haven't been charged in a while, are an issue. Yeah, I think I was out of power. I think I picked 2 semi-dead lipos. It looks a little healthier. Yeah, it looks marginally better. All right, let's try. Turn that off. Let's go all the way forward. There we go. All right, and while we're at it, we can go ahead and screw in one side of one of these guys. So I'm going to take one of these little make-do screws. Put that guy there. All right, and now let me switch cameras over to the front view. So I think that's, yeah, okay, so that's not going to hit the ground there, although it kind of wants to tip over a little bit, probably because of that battery, which is just a weight at this point, so you'll go right there. And I have here a little Adabot that I cut out, colored and cut out from our coloring book. And what I'm going to do is, let's see if I can get this to pause. I'm just going to use a, oops, that didn't pause, but I don't care. I'm going to use a magnet and put Adabot on there. All right, there is our little puppeteered Adabot, and if the Circuit Playground Express will behave, we can do button mode. And obviously this could be a little bit more localized control, so we could have different servos for an arm or the head or the leg. This would be a nice little cutout to make also on separate pieces of cardboard with pivots. So if you wanted to just move the head or move an arm, they could have different pivots on them. But I think that gives hopefully an idea of the type of methods you can use with different types of cardboard, particularly the corrugated fiber board. All right, I'm going to shut this off now. The servo motor using make code, the John Park remembering to keep his audio running, that was a key feature of today, and then some key methods for working with the cardboard, so marking and cutting, and then ultimately using some popsicle sticks and our little brass fasteners to build ourselves a little slider crank mechanism so that we can create this little up and down motion, which is actually kind of tricky with motors and mechanisms to move things linearly. So this is one good way to get something that will move up and down. You can see he's got a little bounce to him as he hits there because our block isn't super precise. Our little piston block isn't super precise there. But that is going to conclude the epic 74-hour-long episode of John Park's Workshop. Thank you, everyone, for stopping by into the chat. I appreciate it greatly. I appreciate you hanging in with me there. Yeah, a 2-hour JP workshop is a fine idea, as you've seen. Whew, I'm tired. It's probably best that we just end this now. But I thank you again for all coming and hanging out. So I'm just going to head over to the machine. I will remind you, because a couple of hours ago I told you about our little coupon code of the day, which is Slider. So if you want to get 10% off in the Adafruit store, fill up your cart with good stuff, and you can get 10% off of the entire order, excluding gift certificates, subscriptions, and software, which we don't actually have right now. So that concludes John Park's workshop. I will see you all over in the Discord chat, and we will be back to hopefully a regular 1-hour length show next week that broadcasts everywhere successfully. So thank you all again. This has been John Park for Adafruit Industries. Bye-bye.